Hey kiddos, one thing I forgot to mention, and I said it's important to do, is take the products and do their enthalpies and get a subtotal. So 2147.7. Take the reactants, and all of the enthalpy is due to propane, has the giggity in it, right? Oxygen has no energy in it, right? So the chemical potential energy is all because of the propane. Anyways, we take that and put it into the reactants and get a subtotal of 103.8. It's important to get that subtotal. So the two subtotals of 2147 and negative 103.8, that's the subtotal for the product, 2147.7. Subtotal for the reactants, negative 103.8. What does that get us? So if we go over here, we can actually put it all onto an enthalpy graph. So that 103.8 we can actually put on as a real number now as the potential energy of the reactants, and it's higher. Even though it's negative, it's 103.8. And the enthalpy of the products, negative 2147.7, which would you rather have in your bank? Negative 103.8 or negative 2147? Clearly, negative 103.8 is a bigger number, so it's higher. That's where the reactants start off with because of the chemical potential energy stored between the bonds, giggity, of the propane. That all gets lost and goes down, and is exo, when you minus the two, negative 43.9. So we can actually use the subtotals of negative 103 and negative 2147, the subtotals that came out of our Hess's Law calculation, we can actually put them straight up onto the enthalpy graph. Right there and there. The actual numbers go right on the graph now. And that's how much potential energy came from the reactants and how much potential energy the products have left in them. Not very much, a lower negative number, for a total of 2043.9.